Okay folks, we are going to look at the spider and the insect problem in your notes that I've set online for you in chapter 2. Okay, it says a hungry spider sees a bug on the ceiling. The picture below shows the spider on the left wall of the room over there. So that, there's the spider on the left wall. What is the closest path along the walls between the spider and the bug? Now, no air travel is allowed, so you can't go and jump from their way to the opposite side of the room. That's what they mean by that. You've got to walk along the walls, or you can go and walk along the ceiling. Okay, so let's see the ceiling and the floor as a wall as well. Make a sketch to show what you think is the shortest path, but make sure to describe how you find this as well. Okay, so what I'm going to do for you now is I'm going to show you how to construct a room where you have the walls as a fixed length. Okay, so we're going to start, and let's say we want our room, we place the dot there. We tell the computer to transform that dot by translating it. Let's say we want our room to be just 8 centimeters long, and that 8 centimeters could represent clearly meters as well, and we want that point translated 180 degrees. Okay, so if I now select this point and I want to move it, it stays. That distance from there to there is 8 centimeters. Okay, I can pick this one. And let's say the room is 4 meters or 3 meters high. So we're going to transform by translating that point a fixed distance, which is 4 meters, let's say, and this time 90 degrees upwards. Okay, so we've got that point there. Now we want to do the same here. We want to construct by translating that point 4 and 90 degrees up. Now we can construct this first side of the room. So if I go and I select all of these and I tell the computer then to construct the segments, it does just that. Now let's make those segments a bit thicker, so medium, because they represent the front wall. So now we want to take all of this, not the picture, we want to take all of this and we want to transform it by translating this. Let's just go with 3 and let's go with 45 degrees. Okay, so that you'll see there is the back wall that we've just drawn there with the same dimensions as the front. So we tell the computer to construct that segment. Let's just make it thick, or what is it, medium. This one we won't see, so we construct it as a segment, but we want that segment to be dashed. Okay, we want a dashed line on that segment. So we're going to tell the PC, we're going to actually, let's just finish putting in these segments, construct that segment, we construct this segment over here. Okay, so I've constructed the 4 segments that I'm going to need, but remember, I'm not going to see, if I look at this from the outside, I don't see those. So I'm going to keep them dashed, and I'm going to make them dashed thin, so that it's clear that if I look at it from this perspective, I have my room. So I'm now going to get rid of my face over here, and let us look at, or let's see if we can go to the one that I've already sort of finished the constructions that we need. Okay, there we go. Okay, so there's the constructions that we needed. Let me just kill my face here. No, let's leave it there because else I must go out. Okay, so now I've placed my spider at A, and I've placed the insect on the back wall at D. Now as you can see, I've constructed, if the spider walks perpendicular to that side, diagonally across, or then walks perpendicular to that side down to the insect. There's the path length. I could also have said, let me find the intersection of this line with that back wall. Let me just construct that intersection. So I could have then said, I'm going to walk that distance, so I'm going to measure that distance, and that distance is AG. Okay, so let me construct the segment AG. Now all of this happens parallel. Okay, this is parallel to that side up there. I clicked on A, I clicked on that side, and I drew the parallel. So I construct the segment over there, and let's make the segment thin, but let's also change the color because we're looking at a separate path. So let's say it walked down that wall, it's in the corner. Now it's going to walk this distance parallel to the roof. So I'm going to construct the parallel line there, and I want to know where that line that I've constructed, let's just keep it as a dotted dashed line. Okay, it's dashed because it's a construction. Then I need to know where it intersects the line where the spider is, or the insect is rather. So I construct that intersection. I tell the PC to measure that distance, so that's the second distance I'm going to use, and I'm telling the PC construct that segment so that it stands out. There we go. This segment here is also, I think, solid. Let's just see. Yes, it is definitely solid. And then I'm going to go up to the hoja and eat it. So I construct that little segment. What is selected? Oh, this side is also selected. I unselect all of this rather, and then I go and I say construct that segment and also measure the length of that segment there, or measure the distance. These length ones are so ugly too. So I'm going to say from there to there, measure the distance. Okay, so that's my second path that I can take. Now I'm going to tell the PC to measure the length of that path. Calculate AG, which is over there. I add to AG, I add HG, and then I add the last one, and we can see that already that path is shorter than the previous one. But now it depends, all of this depends on where the spider is. So I move point A, you can see there's going to be a point, if the spider was over there, where the top might be smaller or quicker to go through than the bottom. Okay, but that's what we've got so far in our construction of how the spider should walk. So is this then the shortest way possible to get to the insect? Well, we don't know. It depends on where we run and how we walk. If I put a variable point on one of these sides here, this corner, that it sort of walks obliquely that way, walks obliquely to that point, whatever the case might be, I might just find a shorter way to do this. Okay, so let's see. The ceiling is definitely longer by the looks of it, because here you go wall, and then you're on the same wall, you just need to walk up. Now remember, the sum of these two is going to be more the triangle inequality. The sum of these two sides is going to be further than if he had just walked straight to D in a diagonal for this little triangle. So let's measure that distance. Let's measure the distance, and let's construct, I must unselect that. So let's also construct this segment over there. So if we construct that segment, then we have its distance, which is GD, and we have AG. So we can say, computer, calculate the distance from A to G, which is that one, plus the distance from G to D, which is this one. Okay, it's done that, and already I've got a shorter distance. So there's a lot of things happening here. Every time I change something, then the path becomes absolutely shorter. So what if I have a variable point here? Let's put a variable point on that wall so that it does not necessarily run parallel. We tell the PC to measure that distance for us, so it is assigned a vertex to there. Okay, and then from that vertex, because we're on the back wall, we're going to go straight for where the insect is. So we construct that segment, we measure, and we want to measure the distance between I and D. So measure, where is it now? Measure that distance. Okay, so I also need to construct between A and I need to construct a segment. Okay, so now we're going to tell the computer number to calculate AI plus ID. Okay, so there, oh, look at that. It's even shorter than all the distances that I've had so far. So let's move now. Remember, now I'm doing Driscoll's work, where I'm going to vary things and I'm going to keep things the same. So A and D, their positions are going to be the same. I'm going to move I up and down, and I want us to look at what happens to the pink and compare it to the other three. So if I move my point I, okay, I'm not going to, let me just keep that one where it is. So just keep an I on this AI plus ID. If I now move it up, we can see there it becomes more. If I move it down, it seemed to plateau at 11. Now let's tell the PC to absolutely give us this distance to where? Label the value to hundreds of thousands. Okay, so we've got there. Let's just go back here again. I want this value at hundreds of thousands, and there it does. So let's see if I move the point I even more. It's 488, 236, 45. Look at this, 1045. I'm now reading the decimals. 1045, 10914, 10842, 10828. That seems to be the point where this spider should actually cross the back wall to get to the insect in the quickest way possible. Okay, now that's interesting. That's very, very interesting. I've got the position for D there, and the shortest will be to go at point I. Well, now I can measure this over there, and let's see how far from the floor measure that distance. How are we going to describe it? Okay, so we're going to say the spider walks to a point on the opposite wall at this corner, which is 1.21 meters above the ground. Remember, this bottom space is the ground, and then walks from there directly to where the insect is to catch the insect. Okay, so we've got to try and find a way where we talk about this and we talk about it more effectively. Okay, so that's the first part of this video. Part 2 will follow soon.